Okay, for problem number 33, we could look at the figure on problem 34. It's the same one. And I also have it graphed on my graphing calculator. You can see there on the screen. But it says the length of this curve is longer than FG. About how many coordinate units long is FG? So now we can find the distance of FG by looking at the coordinate points. And it's not real hard. There's two ways you could do it. One is you could do the distance formula from F to G, right? So we see that F is at the point 0, 200. And we see that G is at the point 200, 0, right? And so let me zoom out a little bit. And it looks like this, where this is 200 and this is 200. Well, that's a right triangle, all right? And this is F and this is G. And they really want us to figure out the length of the hypotenuse. All right, so now how do I figure out the length of the hypotenuse? Well, it's not that hard. What I could simply do is just do the Pythagorean theorem. 200 squared plus 200 squared is equal to FG squared. Does that make sense? So then I could do that on my calculator. And technically, to find the length of FG, I would take the square root of 200 squared plus 200 squared. And when you, in other words, if I take the square root of this and the square root of this, I'm just left with FG. And we're just going to focus on the principal root, right? We know that when we take the square root of anything, there's a positive and negative solution. But really, truthfully, we don't care about the negative solution because we don't think of negative distance, right? So I've got one too many zeros there. So I'm taking the square root of 200 squared plus 200 squared, and I get about 282. So this is 283 if I were to approximate. Okay, does that make sense to you guys? Now, what we want to do is, what answer was that? That was D, right? Does that make sense? The answer is D. Any questions on that? Okay, good.